So, diesel engines, seen in the world today. From when you buy a shirt, it probably came from China or something, right? Gets on a boat, and then gets shipped to the US, then onto a train, to then to a truck stop, or gets put on a truck, then to the store where you buy it. Well, every single part of those is powered by diesel. Hello, my name is Patrick Coombe, and I'd like to introduce you back to diesel. In 1885, Rudolf Karl Diesel here was looking for a newer, more efficient way to run engines to power vehicles of that time. So by 1993, he created this one single-cylinder prototype of the diesel engine as seen here. This created 25 horsepower and ran off peanut oil to be the first. Was the first kind of fuel before the carbon fuel was produced. In 1913, this inventor of this engine went missing. He went to his, I think it was Scotland, his cabin in Scotland, and suicide or kidnapping was both seen as an option, but no one was able to ever find his body, nothing. We don't know anything that happened to him. He just went missing. Now, Plessy Cummins down here on the bottom here was the perfecter of the diesel engine due to the fact that he created a fuel injector that is now seen in today's world. That can also be seen in this, when the orange fills up there, that's the liquid fuel injector that Cummins produced. Cummins also was the founder of the Cummins Engine Company that is now producing engines for almost any size vehicle today, and also was the first person to race a diesel-powered car in the 500. Now, another thing diesel engines are very known for is their horsepower. So the industry standard is brake power. Brake power is 12 times RPM times 33,000 times 1 foot times 1 minute. So we're going to use data off a Caterpillar C15 engine here and do 1,550 foot-pounds of torque times 2,000 RPM divided by all these numbers on the bottom, and you get 590 horsepower. Now, you take that 590 horsepower, and then this engine's rated at 625 horsepower. Divide those two, and you get 94% efficiency. Well, if you were to actually take the max of both these torque and RPM from and put them into that formula, you get 119 horsepower. Now, will that engine run at 1,819 horsepower? Yes, probably for not more than 30 or 40 seconds, then it'll blow up. But that's where this concept comes in here. These two cylinders I have here, they're out of tractors from our farm. This one could be, either one of these could be fit into a 90 horsepower tractor or a 160 horsepower. By using the same size block, a 90 horsepower tractor just produces straight power, no turbo, no nothing. A 160 horsepower tractor uses an intercooler, turbo, larger radiator, larger fuel pump, larger fan, larger everything to pump engine components, but using the same size block, same size piston, everything to create that power. Now, power is created by using the 4-stroke cylinder diagram here. So you'll intake air here, compress it, inject the fine mist of fuel, and then just push that thing off. Also seen in this diagram right here, playing next to it. Now, another thing about diesel engines is that you can use indicated power, which is here. Indicated power, I did not have the data to calculate my own calculations from. I used the sample problem from the book I got the equation from. Now, friction power is because of the fact that it matters that these cylinders, these springs along here on the cylinder, compress when going up and down the friction, so you have the loss of friction seen there. Now, so diesel engines are in everything from mine trucks to trains, boats, cars, tractors, and trucks. Though the mine truck may not actually use the diesel power for their actual drivetrain, they use the diesel engine to power a generator to then power their electrical drivetrain. And everything comes. And so some interesting facts about diesel engines. The fact of the matter is that this diesel fuel here is 85% carbon, 12% hydrogen. And the other 3% I do not know off the top of my head. It's industry secrets. This actual fuel boils at 345 degrees Celsius higher than jet fuel or kerosene. And also, if you're to throw a match into this cup of diesel fuel right now, it will actually the match will actually go out to the fact that it's not under the compression or the heat necessary to make the diesel fuel fire to create the mist that it's used. Now, diesel engines perform better get better power than gas engines at higher altitudes. The fact that the air is already denser and when compressed, you're going to add more fuel to it, and it will make the engine run smooth. These engines perform better at speeds below 65 miles per hour due to the fact that they're a low RPM, high-end torque engine. Produced why that they're really good at hauling heavy loads and other such things. The first American-made diesel truck hit the market in 1933, produced by Kenworth, a popular semi-brand today. And what they do, they're just the first people to actually manufacture the diesel engine and put it on their line as a standard option for for their big rigs at the time. Diesel engines outlast gas engines by hundreds of thousands of miles because they are so durable. As you can see when you pick this up, this is not it's actually a pretty heavy thing. It's not that heavy, it's about probably I'd say 10 or 15 pounds, but for something to have 6 of them in an engine is pretty good. More than 50% of new cars sold in Europe are actually diesel cars. Europe believes that the diesel engine is actually more efficient and gets better gas mileage and everything than the gas engines at the time, and are better for the environment. Diesel engines power our world. Thanks.